Hi, in this video, we are going to go over alkanes and condensed structures of alkanes. So alkanes have only carbon-carbon single bonds and carbon-hydrogen bonds. Chain alkanes have molecular formulas of CnH2n plus 2, where N is the number of carbon atoms. So if there are 2 carbon atoms, it would be Cn or C2H6. Saturated hydrocarbons, so alkanes are saturated hydrocarbons, which means they contain the maximum number of hydrogen atoms for the given number of carbon atoms. And all carbon atoms have tetrahedral geometry. So here in methane, you can see that carbon is attached, all 4 bonds of carbon, because remember carbon can bond to 4 different things, is bonded to a hydrogen. And the geometry, the molecular and electron geometry, is tetrahedral with bond angles of 109.5 degrees. Ethane is a 2-carbon alkane. Each carbon is bonded to each other, so it has a single bond between the carbons, and the rest of the bonds of carbon are bonded to hydrogen, which means that the maximum number of hydrogens are there, so it's saturated with hydrogens. This is another picture, methane, ethane, and then this is pentane. This is 5 carbons, and you can see that due to the tetrahedral geometry of the 109.5 degree bond angles, it forms kind of a zigzag structure for their geometry, and that will be important later when we go over skeletal line structures. And then you can see that each carbon is bonded single bond, so single bond to carbons and single bonds to hydrogens. Every carbon is bonded to as many hydrogens as left with their bonds. So there are 2 different types of shorthand notations for alkanes. There's condensed structures, where the carbon atoms are attached and their attached hydrogen atoms are donated as CHN groups, where N is the number of hydrogen atoms with bonds to the carbon. There's 4 different types of CHN groups. There's CH3, where there's 3 hydrogens bonded to the carbon atom, CH2, CH, and C, where C is there are no hydrogens bonded to that carbon atom. And then there are skeletal line structures. And this is based on that zigzag conformation of the molecule that I just showed you. And all the carbon and hydrogen atom layers are omitted. So this is an example of butane. This is the expanded structure or the Lewis structure. What we saw before, the condensed structure is showing this C. So this is a carbon bonded to 3 hydrogens. It's showing it as a CH3 instead. This is CH2. This green is CH2. It's shown as CH2, another CH2, and then it ends CH3. We usually write it left to right because we read left to right, so that's usually how it's written in the condensed structure. The skeletal line structure is the zigzag right here, and there's a carbon at each end and each bend. So there are 4 carbons in the structure, 1, 2, 3, 4. This will be covered in a later video, but those are the 2 different shorthand notations for alkanes. For condensed structures, this is the displayed formula, and you can see here that this is a CH3 group, a CH2, CH2, and CH3 group. You can write it out as a structural formula this way, but the condensed formula, you don't want to write out so many CH2s. If you have straight chain alkanes, really long ones, you're going to have a lot of CH2s. So usually what you write is you do your bookends of your CH3s, and in between, you have your CH2s in parentheses, and the number subscript afterwards is the number of CH2 groups you have in the middle. So here we have 2 CH2s, and that is how you get your 2 number down here. So for practice, write a Lewis structure for CH3, CH26, CH3. So pause the video, work on that, and then when you're ready, unpause and we'll go over it. So for this, What I'm going to do is I'm going to first write my CH3 group, so CH3, and then I have 6 CH2 groups. So I'm going to write out 6 carbons, 1, 2, 3, 4, 5, 6, and each one has 2 hydrogens bonded to it. So I'm going to write out my hydrogens. This is 1, 2, 3, 4, 5, 6. And then on the right-hand side at the very end, I have another CH3 group. So that is the Lewis structure for this condensed notation. So then those are straight chained alkanes. Now we have branched alkanes, or when there is a substituent or a branch coming off that straight chain. There's the sequence of carbons are written from one end of the carbon chain to another. It doesn't matter which end you start with, but remember, we usually do it left to right because that's the way we read. Branch bonds are drawn either above or below the chain at the branching carbon. So that is the carbon that the branch is bonded to. Or they're placed in parentheses following the carbon group to which it is attached. So these are the 2 different ways to do it. We see we have a CH3 group, a carbon bonded to a hydrogen, and this alkyl branch group, so the CH3 group. We see here we have carbon bonded to this hydrogen and this CH3 group. So there's 2 different ways to write it. You can write it as a branch, so coming off the actual condensed structure, or you can write it as the carbon is bonded to the hydrogen, and then these parentheses mean that it's the branch. So the carbon is bonded to a hydrogen and a CH3 branch, and then this is the rest of the molecule. So for example, 2,2,5-trimethyl-octane, that's the name of this alkane. We see that at carbon 2, we have 2 methyls coming off of it, 2 CH3 groups. You can either write it coming up and down as actual branches, or you can write it as your carbon is bonded to your branches. And then you do the same thing for your next branch. So then you write your CH2s, your regular CH2, CH2 right here. And then you have your carbon branch to another methyl group and so forth. And your carbon, and this is another branch. Don't get this confused when we have a CH3, CH2, 6, CH3. When we have this in our condensed notation, this is not a branch for our straight chain. So make sure you remember, you notice that this is not a branch, but this carbon attached to 2 CH3s is a branch. So write a condensed structure for the Lewis structure below. So practice. So pause the video, work on this, and when you're ready, we will go over it together. So first what I'm going to do is I'm going to go from left to right. So we have a CH3, and then I have a CH. I have a branch. I'm going to put it in parentheses. In my branch, I have a CH2. I'm going to read from bottom to top. And then I have so this is my CH2. And then I have a CH3. So CH3. All of that is in parentheses because this whole thing is a branch. And then I have CH2, 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 CH3. So there's 3 CH2s in there and a CH3. You can also write it as CH3, CH2, CH3, CH2, 3, CH3, where this is your branch and this is part of your chain, right? This is your CH2 3s. Either one works. You just have to make sure you remember that the branch and your chain parentheses are different. So in summary, alkanes are saturated hydrocarbons, which means they have the maximum number of hydrogens per carbon atom, and their molecular formula is CnH2n plus 2, where N is the number of carbons. Each carbon center in an alkane has a tetrahedral electron in molecular geometry with bond angles of 109.5. And condensed structures are shorthand notations for writing structures in which the sequence of carbon groups, which are the C, CH, CH2, and CH3, is given and the CC bonds are omitted. So the actual drawing out of the bonds is omitted.